In this clip, what we're going to look at is we're going to look at finding the nth term from a sequence. Now, the nth term is an algebraic expression that allows us to find any value of any term within a sequence. So, if we look at the first sequence here, which is 5, 9, 13, 17, if I asked you to find the 50th term in that sequence, it would be quite difficult to do. But by finding the nth term, what we can do is we can write the sequence as an algebraic expression and substitute in 50 to go and find the 50th term. So what I'm going to do is I'm going to show you some practical applications of sequences that go up, 5, 9, 13, 17, and sequences that go down, 20, 17, 14, and 11. Now in these questions, what we're going to do is we're going to find the value of the nth term, and then from using the nth term, we're going to give you the value of the 10th term, the 50th term, and the 500th term. Now, if we look at the first one here, it's a very, very simple process. So if we look at 5, 9, 13, 17, the first thing that we notice is that it goes up in fours. So, if you can think of another sequence that goes up in fours, I think the sequence that you'll be thinking about is 4, 8, 12, 16. So essentially what you're looking at is you're looking at the 4 times tables. So essentially the start of the nth term becomes 4n. Now, this sequence here, 5, 9, 13, 17, is essentially a version of the 4 times tables, but it's just a little bit different. So what we're going to do is we're going to simply write down the 4 times tables underneath our sequence. Now, when you look at the 4 times tables mapped onto our new version of the 4 times tables, there is another pattern. 4 to 5, 8 to 9, 12 to 13, 16 to 17. So, how we get from the normal times tables to this new sequence of the times tables is simply that we add 1. Now, the second part of the question asks us to find the value of the 10th term, the 50th term, and the 500th term. So to find the value of the 10th term, what we do is we should say it's 4, because it's the 4 times tables, times 10 plus 1, which is 41. To find the value of the 50th term, we would do the same thing again. We would do 4 times 50, which is 200, plus 1, which is 201. To find the value of the 500th term, we would do the same thing again, where we would times 4 by 500, which is 2000, plus 1, which is 2001. Now, when we come to sequences that descend, what we notice about this one, we've got 20, 17, 14, and 11, and we notice that the sequence is going down by 3. So again, essentially what we're looking at, just very similar to what we did previously, is that we're looking at, this is actually the minus 3 times tables. So it's minus 3n. So what we're looking at now is we're going to start off with our minus 3 times tables, which will become minus 3, minus 6, minus 9, minus 12. Now, again, very, very similar to what we have to do here. We have to know where does the proper times tables map onto the new sequence that we have. Now, it's a little bit more difficult, so you've got to say to yourself, well, how do I get from minus 3 all the way up to 20? Well, I know that I've got to make it bigger, so I'm adding. So, minus 3 plus 3 gets you to 0, plus another 20 gets you to 20, so it's plus 23. And you can see, minus 6 plus 23 is 17, minus 9 plus 23 is 24, minus 12 plus 13 is 23 equals 11. So it's minus 3 plus 23. So, again, very similar to what we've done previously. To find the value of the 10th term of the sequence, it's minus 3 times by 10 plus 23. So minus 3 times 10 is minus 30, plus 23 is minus 7. For the next one, what we're looking at is we're looking at minus 3 times 50 plus 23. So, minus 3 times 50 is minus 150, plus 23 is equal to minus 127. We can apply the same to the 500th term, where we substitute 500 into the sequence and come up with our value for that term also. And that's how you find the nth term and apply the nth term.